All right, so some of the adaptations that help our nocturnal animals to survive in their environment, finding food, water, and shelter, everything that they need, some space. And, you know, we could have a presentation on each one of these adaptations, but the next few slides, I'm just going to be focusing on the first 3 adaptations for you all. And does anyone know what kind of owl this is? It can come in this gray phase or a red rufous phase. It's about this tall. A screech owl, yes, a screech owl. Some of you have put up houses, boxes for them, and have become good landlords of some screech owls out here. Fun fact, owl eyes, kind of the first adaptation, they have their eyes get bigger, they have very large eyes, make up about 5% of its body weight. So they have a lot of their mass is in their eye that helps them to survive in that nocturnal environment. All right, as I mentioned, I'm going to talk a little bit. What am I going back? Oh, yep, I'm going to touch on that, the tapetum. It's a structure in the eye, and wow, there's a lot going on here. Wow. So I'm going to touch on it really quick. So from the previous slide, we have light receptor cells, and you can kind of see the structure of the day animal and the nocturnal animal. And so we're really talking about rods and cones, and we'll talk a little bit more about that in the next slide as well. So like humans, you know, we have more cones than rods. Cones are helping us to, you know, deal with bright light because we're up more during the day, registering detail. Nocturnal animals tend to have more rods because, you know, it's not very bright out, and they just need basic visual information. Now, something that nocturnal animal has is that tapetum layer, and you can see it's displayed right there behind the retina. So the idea is that light comes in through the pupil. You know, these animals, their pupils are going to dilate the same that ours do when we're in a darkly lit room. So light comes through, it goes through the retina, and light is absorbed in the retina. If there's light that isn't absorbed by the retina, it hits the tapetum layer, and it's kind of like a mirror-like surface. And what it allows the light to do, it bounces it back and gives the retina a second chance to absorb that light. So taking advantage and helping us see better in that low light environment. And light that's not absorbed the second time exits back out through the pupil. And there's the next few slides, we'll kind of talk about like how we see that, and it comes out as light shine. If you've ever spotlighted for animals, you see that the tapetum reflected back in there. So there's a lot going on with this nocturnal eye, but the main points are rods and cones, how it's different between day versus night, and then that tapetum layer. So it's supposed to look like it's superimposed, but you've all heard the phrase, the deer in headlights, right?
Yes.
All right, so the deer in headlights, and so what happens, and many of you probably have experiences this as well, if you are in a very brightly lit room, and then all of a sudden you go into a very dark space, you can't see things very well. You're kind of like holding on for a minute before you can move about. The same thing happens if you're in a darkly lit area and all of a sudden the lights flashes on and you kind of are blinded for a bit. It's the same thing that happens with our nocturnal animals. Because they have more rods than cones, if they get, you know, saturated with a spotlight or a headlight, they kind of freeze because they can't figure out what's going on. And it can take about 10 to 40 minutes for them to regain their night vision. And if they're in, you know, kind of near a roadway, or if there's predators about, then that can make them more vulnerable in that setting. So that's kind of where that phrase comes from, a deer in headlights. And here are some examples of the tapetum reflection, right? And so it depends on the type of light that you're using, the angle that you view the animal, and then there's different animals have kind of different minerals that make up that layer, and so you're going to get different eye shine, and you can sometimes identify the animal just by the color of the eye shine. The alligators, kind of an orange orangish red shine. Some other animals are greenish or blues or whites. And I think everyone has a pretty good idea of some of these, but this might be the challenge. Does anyone recognize this bird? Sometimes in the early mornings you can hear it calling. Some people have mistaken it as a whippoorwill. Yeah, Chuck-bill's widow. They're in a goatsucker family. They have very large mouths, and one of their other adaptations is that they have like those sensory hairs to kind of take advantage of low light environments, and they nest on the ground. So, and this is something that we see on some of our trail cameras or when we go around for spotlight surveys. This is why we take advantage of using those surveys because of that eyeshine, but it only works with animals.